So here's my first slide, borrowing from Hunter S. Thompson. We've heard about the Fair Data Campaign trail this morning, but the usual reaction of a MagLab user, and a couple of years ago, even the MagLab user committee, was easily characterized as fear and loathing, both fear that this meant the data would be disseminated before they'd had time to make sense of it, since experiments are often extended over multiple years, and loathing that it would just take more time that without return on the investment there. And we've heard arguments for why we should rethink how we should be thinking about fair data. But my goal here is rather to say, if you have an SF grant, if you use MagLab, there's a fair data requirement. How can you make it something that will actually clearly benefit you and make it as easy as possible to then share it without extra work? And so the tool that I have been using in that regard, and I need to change what my sharing is. The tool I've been using in that regard is wherever Firefox went. Okay. Nope, here we go. Now you should be seeing Physics 350 and an OSF IO website.
We see a very small white bar.
Okay, so we will try again on that regard. And here we go. This is better, right?
Yes.
Okay.
Yes.
So just a little fear and loathing on the Zoom presentation trail to get you started. My motivation here actually came for using OSF had nothing to do with fair data at all. It had to do with looking for a way of understanding what my students were doing in advanced lab, and in particular, understand where the data they were generating was coming from and how to get them to learn how to use an electronic notebook without me spending any money. And so this course tries to teach them everything from how to pull a signal out of a noise, to how to keep a notebook, to how to document what you've done, to how to publish your results. They were really falling down on the how to keep the notebook part. Typically there'd be a nice sketch of the experiment and there'd be 4 columns, each of the data columns labeled volts. Okay, so then somehow that generated a figure which wasn't what they must have collected, but how to do the forensic analysis. So we started with OSF, both so that the students could collaborate with each other, so that they could write down what they were doing, and they could upload their data and the like. So for example, if they have to put the data in a spreadsheet and then be able to upload it in order to graph it and say that we're looking at a Python notebook here, a Jupyter notebook running Python, then they have to have some reasonable name for the text files. And they have to, and the analysis they've done to generate the figure is there before you. And you can see if there was, if it makes sense, if there's a different way to go about it, how they might interpret the data, and compare one group to another. Like, what did they include in the analysis? And even then extend it, allow them to do things like look at the residuals, what's happening to the data there. What do you think about that then for the error bars you generated? And it might occur to you at this point that that was a really good thing for experimenters to do it as well. But it took me a little more time to get to that point. So I started using OSF for my research lab as well, because I couldn't afford lab archives, right? The models for those commercial ones are where you either have something for a course and all the data goes away at the end of the semester, or you have something with postdocs and you're paying $100 to $1,000 per postdoc that you add. I can't do that with half a dozen undergraduates in my lab running, working for anywhere from 2 to 10 hours a week for anywhere from 2 weeks to 2 years. And so how might we keep track of all our stuff? And so we thought we would try OSF for that too. And you can have an operations log. You can check on what's going on there, and then just be writing down what you did in a particular cooldown in their wiki. And I really don't think the OSF, as the wiki, the electronic notebook part is particularly powerful. There's, for example, there isn't a way to automatically time date stamp an entry. You need to do it by hand. But this is GitHub flavored Markdown, so it allows tables, figures, graphs, LaTeX, the work. It has everything that they need for entering data, and it's also the same way that you post comments in a file within the file within a Jupyter Notebook file itself. So it was it worked very well in that regard and for keeping track of things, particularly since there's so many students coming and going in the lab and just learning how to use different pieces of equipment. But I think the thing that finally pushed me over the edge to using it in MagLab experiments itself was trying to go back and recreate, once COVID hit, how to recreate 5 years worth of data that had been collected on a system through 3 years of experiments at the lab, 2 years of experiments elsewhere, consolidate that into some sort of understanding, and then discovering, okay, where did that figure come from? How was it generated? Which Igor file or where was the data for that versus the other? And it being, and oh, was that on the older computer or the newer computer, right? And oh, you have this figure, well, and it came from Origin, but where's the data that went to it? Well, I don't know. And it was, the pandemic gave me a chance to finally sit down and figure out what was going on in this data. And we got a paper out of it there. But I mean, I actually spent the first couple of months just trying to reassemble all the data, put it together, tag each data with each calibration, figure out, how to reconcile the things. It was a lot of unnecessary work just to recreate stuff that we had because it had been spread out over so long a time. And so in OSF, you can just go for it. You can build all kinds of components for all kinds of data, that going from the raw data to the figures. And typically what we do is we have something that has the software for the analysis, the stuff for the calibrations, the raw data, and some process data. Now, rather than go, and so this can be fairly involved. For example, I might have the data log for what I did in a particular magnet run, or I might have the way that I calibrated the magnetic field. I might have the data that I have on there, or I might have the way that I calibrated the magnet, something in a magnetic field at 7 Tesla. And because I have the data processed, and then I have the graphs being generated using a software app, in this case Python, I can reproducibly generate the graph, change the fitting, and verify how good the fit was. And I need to do this at multiple fields in order to correct for the magnetoresistance thermometer. I can see how good the fractional error is in temperature at 7 Tesla. I can have a set of these at 0, 7, 14, 21, 28 Tesla. And then if I have an opportunity to go up to higher Tesla, I can add that data, then rerun the calibration and probably modify the fit to do a better predictor at high field of how temperature is changing, how resistance is changing with temperature. So there's a lot of value there. And I'm keeping track of the time here to move on to then what I thought after the effect would be a nice way to organize files. And so what I'm turning to now is a template that sort of illustrates what my current thinking is regarding how to make data recoverable, reusable, reanalyzable, particularly when you're working with collaborations and particularly when you're working with students, by making that into smaller documentable steps. And I would say this, I mean, this template is freely available to you now. And there's a link was sent to you. I can put another in the chat later. But here too, I mean, I'm using OSF for other reasons originally. It's a little hard to revise a template once you have it here. So for example, you're going to see I have components for the instrumentation files, instrumentation settings, the sensors, the raw data, the data after it's been edited just very sparingly for glitches and for joining files or separating if I have a field sweep and field down in the same file, the calibrated data, and then process data. At this point, you might have thought, why don't you just make something said data and then have a series of these components within that? Well, I don't know how to do that within OSF. Maybe somebody else does, but it's not the sort of thing where you can easily move other folders inside of other folders. You need to have some idea of what you were looking for in the first place. And it's quite possible that you might want to modify this in a way that requires you to start from scratch. Nonetheless, OSF has worked well for this, and I thought I'd walk you through the typical things that I do now. So DAC instrumentation files are something that I don't actually have yet for this thing, for my current data acquisition system. One that I had INI files that would have the list of commands that were needed for an experiment, for an instrument to communicate with it, and the settings that I want. So I could have preset settings. I could imagine such files could also be generated capturing whatever the file, whatever the instrument settings are at that moment. And so this is a future hope for that. But now if we go back to here, sensors and calibrations, I have a lot of there. In part, starting with a zero field calibrated commercial thermometer. You can create a wiki that will create a list of what these thermometers are, but you can also create components for each one of these here. And so like say if I do the one for a Lakeshore Cernox here, by creating a component for it, that means that this sensor has a unique URL, a unique, I mean, you can see it here in the citation. Even that, you know, if you go to OSF with this thing here, you're going to go to the sensor page. And so this is a ERSAT's way of issuing an ID, a DOI, universal ID for a sensor itself, at least for where you could find the calibration data. And so I can have I can see what the data is that came from Lakeshore when they provided it. And I can see how I generated a calibration for that and how good it was. That was the basis for then a field dependent calibration later. I can see, you know, what did I do to the data? How did I decide what order of Chebyshev fit to use? What the resulting fit was? What the sensitivity looked like, and what the error is in fractional resistance and fractional temperature. And I think it's pretty good, you know, over that full temperature span. And so again, my main conclusion is Lakeshore needed to take a lot more data between 0.1 Kelvin and 1 Kelvin. If I added to it, I could rerun this. If you're listening, Lakeshore, you need, for what we pay to get the colder data, you ought to give us more of it. All right. So I'm censoring most of my editorial comments, believe it or not. But as we move along, I can therefore find what I did with each of these. And similarly, I can do it for the calibrations of the thermometers I prepare myself and then go forwards there. And so I can link to this on a wiki page describing then the analysis that I do. Now, what's the next step in the process is collecting the data itself. And this is where not only will I have the raw data files, but I'll also have something that functions like a lab notebook to explain like what did I do during each run and what was happening. Now, this is just the general log. And normally when you're collecting data, you might type comments in a window in your data acquisition program. And if those comments could be changed from a text file to a markdown compatible text file, they could immediately be uploaded as wiki files here, along with the data itself, where you include things like, well, what was the orientation of the calorimeter? What did happen during this data? Apparently nothing. And what went wrong with overnight with the temperature of the sample. Turns out there's a radio station very near the lab that should be purchased and destroyed. But going further then, once you have your raw data, this is something that I think could be easily, the programs could be modified to upload this using an OSF API and to upload the comments as the wikis there. And then already you have a starting point that you can recover from. I would recommend something then that has the data just after you've edited it and parsed it into files. Any filtering if you've done, and if you do that, then you would also include the software. You would include the Jupyter notebook that showed that parsing or showed that filtering so that you could recover it later. For example, in the one of the 5 years of data on the barium compound, it was clear that the initial graphs that had been made have too over-filtered the results, and it was work to go back and to recover the original unfiltered data and to smooth everything in a self-consistent manner. So that could have been here at the time. I think in order to make the stuff recoverable and to track what's doing, breaking it into small steps is important. Cleaning the data for glitches and then a calibration, because the calibrated data is then something that maybe you have to convert from volts to your actual units. Maybe you need to use your calibration there, and you might change the calibration as you update it, or you discover that you remeasure your reference thermometer and discover that it was out of calibration. This allows you to go at this step without going back to the earlier step and still be able to recover your data and reproduce your results. Finally, you're going to need some data analysis, and you're going to want to keep track of what you did. And this might be something as simple as capturing the command line when you're doing editing in Igor, which is easily done, or in having the analysis be step-by-step within a Python file. You might do batch processing or something like that, but still there should be a way to document what you did in this regard. And again, the wikis help explain what is there. And if you keep the software that you use for that step tied to the file, each file in the data, then it's recoverable. Finally, the process data then leads to, and data graphs are things that I have here, because I've discovered that no matter how you format a graph, you're going to need to reformat it to make the editors and reviewers happy. And it really helps to have just that data and just that code that generated that graph there to rerun it in the new font that's required. So where are we now? I was supposed to go for 20 minutes and then like 10 minutes for questions. I've shown you the way that I would present this data and in order to track what was done and then to be able to revise and check what has been done. And maybe this structure would work for you as well. If you want to make it fair, then you need to add tags to add search terms for each of these things to make it discoverable. And for example, it might be that you don't need to share the raw data, just the calibrated data. Then it's not worthwhile to do something else. Okay, so I misspelled calibrated data. And you can add the links to the routines that you used in order to process it in the first place. Now that's actually going to take me to a different site. So let's not do that right now. what is my broader recommendations? So this is something that works, but it doesn't work automatically. And there's many things that would make things easier. And this is my little opinion piece on what they are that you can read once you look at it here. But the main thing is that the data files could be modified to include not just the column names, but also the units. The gains, that's often there, and the measurement units, you know, if they're different from the instrument units. And this should be a way of entering it as you type in the column names and the gains themselves. Likewise, the comments or information could be spun off as a wiki. And in the follow-ups, that these things would be automatically uploaded if in your data access you entered the address of the OSF file, or if MagLab provided them, you know, in some way. As long as you follow the basic expectation of where the data could be found or put, then this could be done. I also think that as was mentioned by some of the speakers this morning, there's metadata for the whole experiment that could easily be uploaded, that stuff that isn't for each run or each field sweep. And that in order to really make this especially useful, we need databases for samples and for sensors. All right, like particularly for thermometers and the like, and preferably for the instruments that we're using as well, so that you can simply tag the data with the sensor ID or the sample ID and find out like what was its mass, what was its size, you know, what was its name, where did it come from, when was the sensor last calibrated, and so forth. Now, these are things that are relatively easy to do with what is done now, but in a broader step, essentially what we're trying to do is tie the metadata to the data in a way that doesn't require a lot of editing and collating and librarian work afterwards. And I think the accepted way, an accepted way of doing that in an accepted file format is, for example, the HDF5 data file format, where you store all this additional things as file attributes, even such things like as the units of the data. And I think it'd be a much heavier lift to modify the MagLab programs and our own in that way. But if it was done, and then there were tools or sample apps, how to access this data using Igor or Python or LabVIEW, and how to put our own data in that way, we'd get used to it. And that would make it much easier to keep the data with it, even easier than the links within OSF itself. So I'm going to stop here and say it won't hurt me if you decide that this is completely unusable for you. But if you want to use it, or if the lab wants to use it as a starting point for discussion, that's completely fine. I've chosen a license that allows you to modify it in any way you want, including except for throwing it away.
So, thank you, Nat. That
Sure.
was very nice.